Moving on to the next steps here, we need to create the curve on the side that's going to have the proper number of points that we can then modify, that's going to correspond with the profile of how we're peeling it upwards, each of the louvers. So to start off with that, I'm going to create a curve that's on the side, and it's going to have 5 points. So I'm going to do one of these interp curves. Oops, sorry, not that. This curve here. It's important to start the curve on a 0 x-axis, or sorry, on a 0 y-axis. So it doesn't really matter where you started on the x as long as it's further to the right of the building itself, which I think I built it to be 30 feet wide. So if you just do your x value as like 50 feet, here. Started at 50 feet, comma 0. Something like that. And then the way I'm going to do this is just make sure each of the points are established 10 feet apart from one another. So I'll type in 10 feet, hold shift and click, and then 10 feet, hold shift and click, and then 10 feet, shift click, and 10 feet, shift and click, hit enter. So what's going to happen with this curve is when I turn the points on, you guys all know how to do edit points on, right? I think you learned that in your other classes. Essentially, all I have to do is select the points that I want to pull off for my rotational pattern. In this case, for the type of curvature that I want, I'm going to leave points 2 and 4 exactly in line, and the only one I need is the middle one. Kind of like I'm actually picking at it from the center and pulling it upward. Make sense?
So you just move the middle one?
Just the middle one, yep. So I just grab the middle one and I pull it out this way. See how it creates a really nice smooth kind of transition? Now it's going to look in proportion to your building really extreme, but the key is to understand that this is actually a rotational proportion. So imagine if you took this thing flat and you cut it out with a piece of paper and then you curled it upwards, it's really not going to seem all that extreme. Okay, so you'll see when we get there. So anyway, the next steps. We have to create a remote profile that's going to subdivide the curve into 5 points in Grasshopper, and then it's going to create another curve from its origin point to its end point and subdivide that by the same number of points. And it looks a little bit like this. Go below your definition and reference in a new curve. Set one curve, you can set it to that. We're going to need 2 divides. One of them is going to be a little different than the other. So the divide, if we go to curve and division, and we go to divide curve, in fact, I'll just keep it in line with these other divides. The first divide, well actually both of the divides, are going to borrow the same number of subdivisions. It's very, very important that you keep the same number of subdivisions. So to make sure it always is the same number of subdivisions, I'm going to use the same slider that determines my number of subdivisions. You guys like that alliteration, huh? I just Hemingway'd you guys. So anyway, the curve then is going to plug into the C input of divide. And the other one, right, so I need another divide. And it is going to come from the same curve. However, I want it to be a straight line. And so to create a straight line, I'm going to use 2 nodes, one of which I think you've used before, the other one you have not. I'm going to use, obviously, line, and a line is just going to draw a line from one point to another. But in order to do a straight line from the beginning point of this curve to the end point of this curve, I have to first get the beginning point of the curve and the end point of the curve. So that one is called endpoints, which is found under curve and analysis. Actually, is it? Yeah, it is. Endpoints, right here. Now, endpoints is going to take the curve, and it's going to push out the start point and the end point. And then I need to create a line, which is under curve and primitive, right here, line. And notice how it has an A for a start point and a B for an end point. And it looks kind of silly that we're doing it this way, but I think it's fun. So really, the start point plugs into the start point for the line, and the end point plugs into the end point for the line, and then the curve gets plugged in. And what you get is another curve, and then you plug the line into the curve input for your second divide. I know I just walked you through a bunch of things really, really fast, so I'm going to give you a moment to catch up, and then I'll continue on with this thought before we move into the next segment. Moving right along, guys. We have our two subdivisions now, and what we need to do is measure the distance between the two, because the zero distance at the end is going to determine our endpoints to have no rotation. That's how it was flat. And our very large, or relatively larger, rotator distance in the center is going to be determined by the fact that the center one is farthest away. So that looks like this. I forget exactly where this is. Hang on. It's an vector point. Okay. So under vector and point, we have this cool little tool that's called distance, which does nothing more than measure the distance between points. So you go to distance and you measure the distance of the first point list from the second point list. That output looks like this. So you've got 0, 2.1, 5.6, 2.1, and 0. Seems pretty appropriate, right? So what we're going to do is to establish a rotation and then transition or translate these numerical values into radians. And in order to make it something that's parametric, we're basically just going to present a multiplier. And that multiplier is going to let us essentially just say, you know, if my maximum value is going to be, say, 90 degrees, then we could just put it up to, you know, a certain value, and it would push it up. So let's see here. Yeah, so I think that probably does it for this particular section. And then we're going to move into the rotation part next, which will introduce another new tool.